This is a reach.
Okay. I'm already hearing, oh boy. Okay. I'm going to show you some long division stuff. But don't panic. You actually don't need to know any long division. But because I'm going to show you a shortcut. Yay. Okay, so if you don't want to write any long division stuff, you don't have to. If you like to follow me, you can. It's only because I love long division, weirdly enough. It's fun. Okay, so I'm going to show you the long division, and then I'm going to show you a shortcut, and you can always use the shortcut. Okay, so long division would go like this. How many times does 21 fit into 4? It doesn't. How many times does 21 fit into 43? Twice. So 2 times 21 makes 42, and then I subtract and get 1. Then I pull that down. Does this look familiar? What did you say, grade 5 is really the last time you would do this? How many times does 21 go into 10? None. 0 times 21 is 0, which makes 10. Then I bring down the 9. How many times can you fit 21 into 109? 5. 5 times 21 is 105, leaving me with 4. Then I bring down the 7. How many times does 21 fit into 47? Twice. 42. So is 43,079, is it divisible by 21? Yes or no? No. Why not? This is a remainder. Yeah. So it's not divisible. You could keep going and you'd get some decimals, things like that. Okay. I'm going to do a long division with polynomials. And again, you actually are never going to need to do this. Good. Okay? I'm going to do it, but you don't need to do it. Okay, so I have this polynomial divided by this polynomial. That's what we're doing. Okay, I have a problem here. Do you notice how this polynomial starts with a 4th degree and then it goes to a 2nd degree? So when we're working with polynomials, they always have to go down in an order. So I'm actually going to rewrite this with a 0x cubed. Now does it look like it's going in an order all the time, going down in an order? Here's a question. If I start with a 4th degree and divide by an x, what should my result degree be? X cubed. Does that make sense? If you are in x to the 4th and you're going to be dividing by an x, your result's going to be a cubic. Okay, how many times does x go into x to the 4th? X cubed. X cubed times x makes x to the 4th. This times this makes negative 3x cubed. What happens when you subtract that? Gone. What does this make when you subtract it? Positive. And then you bring the next term down. Restart it. how many times does x go into 3x cubed? Like this times what would make that? 3x squared? Does that times that make that? So that times that makes 3x cubed. And then what else here? Minus 9x squared. So you always have to times this by both things, right? Okay, so I subtract, gone. What happens with a negative 3 subtract a negative 9? You get a positive 6. Okay, keep repeating, bring that down. Okay, restart. How many times does x go into 6x squared? 6x. So I'm going to go this times this, and this times this. So 6x squared minus 18x. I'm going to subtract. That's gone. Ooh, more negatives. Negative 15, and that essentially adds 18. So 3x. Bring this down. How many times does x go into 3x? 3. You get 3x minus 9. When you subtract, it's like adding 9. So I get a remainder of 1. Okay, that's the long way. Now we're going to do the short way. Okay, so synthetic division. Okay, so what I'm going to do on the outside here, if my factor is x minus 3, what would the x-intercept be? Positive 3. Okay, now I'm going to write the coefficients of my terms in here, except for we can't do it like that. We also have to make sure we put the 0 in there. So I'm going to go 1, because 1x to the 4th. Then I'm going to go 0 cubes. How many squareds? Negative 3. Then a negative 15. Then a negative 8. I actually... Sorry. When you do this, you actually write it, the box, on the opposite way, but not a big deal. Okay. So on the outside, you put the root, or the x-intercept, or the 0. And on the inside, you put the coefficients, making sure they're in order. So sometimes you got to throw a 0 in somewhere. Okay, step 1. You bring that down. 1. Multiply, you get 3. Now you add 3. Multiply, 9. Add, what does this row add or column add to? 6. Multiply, 18. Add 3. Multiply, 9. Add 1. Okay, what does this all mean? Okay, so we started with a 4th and divided by an x. So what are we resulting in? A cubic, a squared, an x, a number, and a remainder. Does this match what we just did over here? 1x cubed plus 3x squared plus 6x plus 3 and our remainder of 1. Okay, so division statement. x4 minus 3x squared minus 15x minus 8 divided by x minus 3 equals 1x cubed plus 3x squared plus 6x plus 3 plus 1 over x minus 3. So that's the remainder part. Okay, let's try another one. Okay, so I'm going to go, my box actually like that. Sorry, I did it backwards last time. Okay, what value should I put on the outside of this box? Positive 4. Okay, can you check the order here? Are we okay, or do we need to throw a 0 in here somewhere? We went from a cube, square, 1, none. We're good. The order's good. So 3, negative 2, negative 10, negative 120. Okay, so those are the coefficients in order. First step, bring that down. Okay, can you go multiply, add, multiply, add, multiply, add? Continue that pattern. So 12. Add down 10. Multiply 40. Add down 30, multiply 120, add down 0. What can you tell me about a situation if the remainder of something is 0? Is this divisible by this? Yes, it is. I can also tell you right now that x minus 4 is a factor, for sure, because it was a remainder of 0. What else can I tell you at this point? 4 is what? What's so special about 4 on this? It's an x-intercept, or a 0, or a root. You're going to hear all those things somewhere in your books, right? You know that these two facts are now true because of that remainder. Okay, I'm just going to talk about some language here. You might see something like this. Okay, if I had named that function, okay, if I had named that function, this is just a way of naming functions. If I had called it f of x, then I can tell you this statement is true. What does this mean to you? When you plug 4 into the function, f function, so when you replace x with 4, so when you plug a 4 in, the result is 0. Because it's an x-intercept. So when x is 4, y is 0. It's an x-intercept. Okay, so those three facts are true. When the remainder is 0, those are some of the ideas you can come up with. Okay, write a division statement. So this divided by that equals, how do we write the 3, the 10, and the 30? How do we write it? 3 what? So we started cubic and we divided x, so our result is going to be a square plus 10x plus 30. Okay, I also might ask you to do something that's called a product. So a product, if this divided by this equals this, does this times this equal that? Does that make sense? 8 divided by 4 is 2. That is me writing a division. How would I change it to a multiplication? 2 times 4 equals 8. This divided by this equals 4, division. Therefore, I also can write a multiplication. So if I wanted to write a product, I could say this times this equals this. Does that make sense? When you divide, you can go backwards and multiply, right? Okay, number 3. Write the quotient. I just want the quotient here. So we're going to divide, and I just want the result, the quotient. Okay, what number do I want to put on the outside? -3? Okay, look at your degrees. Are we good with order, or did we have a 0 spot? There's no squareds in there. I missed a square. So we have to make sure we're in an order. Okay, so coefficients: 4, 5, 0, -10, -60. Okay, go for it. Let's see if you can try it on your own. So start with that one down. Multiply, add, multiply, add, multiply, add till you get to the end. Remainder 159. Anybody matching me on the remainder? 159. Okay, quotient time. So think back to your start. If this was a 4th dividing by an x, the result would be a cubic. So result is 4x cubed minus 7x squared plus 21x minus 73. How do I write a remainder? Plus 159 over x plus 3. So that's the quotient. That's the result of the division. Okay, the remainder theorem. Okay, so the remainder theorem is trying to decide if it's an x-intercept or not. Okay, so when I look at this, what value of x am I testing to see if it is an x-intercept? You're trying to test an x value of positive 3. Okay, so here I go. 3 to the 4th minus 3 times 3 squared minus 15 times 3 minus 8. So the remainder theorem says if this value is 0, it's an x-intercept, which means this is a factor. Okay, so see what you can come up with there. I want to basically know if it's 0 or not 0. Okay, anybody 1? 1 was good? Okay, so what do I know? 3 is not a root. It's not a root. What else do I know? I know that x minus 3 is not a factor. Okay, number 2, testing using the remainder theorem. What value of x would you like to plug in? Positive 4? Okay, so your math is going to go 3 times 4 cubed, plugging in a 4. See what you can get. I got 0. Someone's got 0, okay. So getting 0, what do I conclude? 4 is a root, or an x-intercept, or a 0. I don't know, any of those words, you might see any of them, they all mean the same thing. You could also make a conclusion that x minus 4 is a factor. You could say that this is divisible by this, right? All those things are true. Okay, last one. I want to just do this because this time I want to make sure you are good with your calculator here. Negative numbers. Can you try this, please, on your calculator? Because I want to know that your negative numbers are good. And 159? You want to know how I cheated like that, didn't you, on your calculator? This button, you can go -3 and store it into your X feature. This is great, and Vince have this calculator. You can store X values in, and then you can do that. 159. So what's the conclusion? -3 is not a 0. X plus 3 is not a factor. Okay, it just has to be 0 with the result. So